What a boring day.
You're telling me. Even the grass is getting bored of watching itself grow.
Oh? How can you tell?
I mean, just look at it.
Well, I like it this way. Nice and calm.
I know. Why don't we visit our friends in the wood shop class?
Yeah, that sounds great.
For once, I agree. Let's do this.
Oh, hey, you guys. It's a surprise to see you here.
We were bored, so we went to see what you guys are doing.
We're doing great. We built an entire birdhouse today.
Oh, wow. That looks like fun. I want to build a birdhouse right now.
Here's the saw. Just be careful with it.
Oh, I will.
Do it. Cut the wood.
Okay. I am going to cut the wood. Yeah.
According to my research, 64% of people who work in wood shops receive some sort of injury. This, of course, includes partial amputations.
Oh! Huh.
Hello, class! I noticed a lot of close-ups were happening and I was nowhere around, so here I am!
Arnold cut his hand off with a woodcutter!
It's called a saw.
Oh no, Arnold, you've hurt yourself! But that's okay, because your cells are currently reproducing and repairing. Or at least they're trying to. It's time for our field trip, class!
But Miss Frizzle, Arnold's bleeding. Shouldn't we take him to, the hospital or something?
Well, according to my research, Arnold's hand would heal and stop bleeding on its own in no time.
You're partially right, Dorothy. Usually, cells reproduce to help repair damaged tissue, which is why when we cut ourselves, it heals up within a few days. But Arnold's wound is a little too big for it to heal on its own that quickly. But that doesn't mean we still can't watch the cells try their best to do it anyway.
Wait, where's Arnold? Wait, where is Arnold, Miss Frizzle? You can't mean that we're...
Going into Arnold's open wound? Why, yes, we are. All right. Now that we're all shrunken down to size, let's find a way into Arnold's arm to watch the wonderful magic of mitosis before our very eyes.
But Miss Frizzle, how are we going to do that?
Oh, brother. I knew I should have stayed home today.
Well, here we are, class. Though, I'm not too sure where here is. Does anyone have a map?
Miss Frizzle, look over there. Arnold's cells are dividing all over the place.
Indeed! They're trying to repair the damaged tissue in Arnold's wrists. It's just one of their jobs.
Hey, how come those cells over there aren't doing anything? If all the cells divided and worked as a team, then they could stop Arnold from bleeding to death.
According to my research, those cells aren't needed to divide. If all our cells kept dividing, we'd look like crazy mutants and grow out of control.
That's right, Dorothy. In fact, there's a name for the process in which cells aren't in division. It's called the G0 phase, when a cell is neither growing nor preparing for cell division.
Phases? That sounds like cell division is going to be a lot more complicated than I thought it was.
Oh, Phoebe, it really isn't that bad. In fact, the cell that's next to Wanda looks like it would be a great way to show you exactly how a cell does division. Put on your suits, children. All we need is for the bus to use its speed or uppertron to make this cell divide faster, and then we can take a closer look. Bus, do your stuff! Miss Frizzle, did anyone call 911 when Arnold cut his hand off? Because I don't remember if anyone did that before we got on the bus.
I don't like this, but you better be quick, you guys. I'm sort of bleeding here. Hey, you guys, are you almost done in there? I'm sort of dying. I mean, learning about cell division is great and all, but blood, me, life, you know, it's,
Okay, everyone, here's that cell I was talking about. Let's watch as it divides, shall we? First, the cell undergoes interphase, which is the biggest phase in cell division. Interphase is split up into 3 parts, G1, S, and G2. G1 stands for the first phase of growth, where the cell grows and does its usual cell things in preparation to get large enough to be able to split into 2 normal-sized cells. Then comes S for synthesis, where the cell copies its genetic material, known as chromatin, so that when the time comes, it has DNA to offer to a new cell. G2 is continued growth, and after that comes M-phase. Additionally, during interphase, the centrosome and centrioles have duplicated to have some for the new cells that will be created. After interphase comes the big show, M-phase. M-phase is the most active part of the cell cycle, but it's also the shortest. First step in M-phase is prophase, where the chromatin becomes more densely packed and turns into clearly visible chromosomes. All the chromosomes bundle together with their respective copies at structures called centromeres, and the nucleoli of the cell disappears. Meanwhile, outside the nucleus, long lines made of microtubules begin to pop out of the centrosomes and meet together in something called the mitotic spindle, where small microtubules that go out in all directions of the centrosomes are called asters. All the while, the centrosomes get farther and farther away from each other, and while the mitotic spindle gets longer.
Whoa! Was that bad that thing just exploded?
Now hold your hamburgers, Wanda. We have nothing to worry about here. That's just the beginning of the next part of M-phase, prometaphase. In prometaphase, the nuclear envelope of the cell breaks apart, freeing the chromosomes to attach to the microtubules of the mitotic spindle. The chromatids of each chromosome gain kinetochores, proteins in the centromere that become anchors for microtubules to latch onto. These microtubules jerk the chromosomes back and forth, swaying the mitotic spindle a little bit.
All this weird organ jiggling in these gooey cells? I think I'm gonna be sick.
Come on, you measly wimp. It's just Arnold's cells.
On to the longest part of M-phase, metaphase. Metaphase lasts about 20 minutes long. By now, the mitotic spindle has come to take up most of the space in the dividing cell, and the centrosomes now lie at opposite ends of the cell, with the chromosomes all lined up about halfway between the centrosomes on an imaginary line called the metaphase plate. Next is anaphase, which begins when the cohesion proteins that anchor the microtubules to each other and the sister chromatids is broken, causing the sister chromatids to pull apart and become chromosomes. Microtubules pull the chromosomes to their respective sides of the cell, all while the cell is slowly getting longer. Then comes the last part of M-phase, telophase. During telophase, 2 nuclei have formed in the cell, with nuclear envelopes made from the old, fragmented one, and various organelles start to form. The chromosomes start reverting back to their loose, unorganized state, and then M-phase finishes. During telophase, the cell had begun to form a cleavage furrow, a line that would demarcate where exactly the cell would split into two, which deepens and deepens until cytokinesis, where the cell does actually split into two genetically identical cells. Now, class, wasn't that fun? All right, let's get back to Arnold and see how he's holding up. Arnold, we're back!
I told you we should have taken to the hospital. Why? No. Why? Why did it have to be this way? It didn't have to be this way. No, Arnold.
Goodbye. Goodbye, my hand.